6. haftasına hoş geldiniz. Ben kaydı başlattım. Sözü Ammar hocama bırakıyorum. Teşekkür ederim Ammar hocam.
Ben teşekkür
Abbas
ederim.
hocam. Abbas hocam. Ammar
Abbas'ı
hocam.
tercih ederim hocam. Aynen.
Tamam Abbas hocam. Teşekkür ederim Abbas hocam. Kolay gelsin.
Teşekkürler hocam. Merhaba arkadaşlar. 10 kişi olmuşuz. Toplanmışız. Tamam. Süper. Zaten aktif olarak katılan bundan fazla öğrencimiz çok olmadı. Hepinize merhaba tekrar. Ömer yazdığını gördüm. Muharrem hocamla konuşuyordum. Merhaba. Arkadaşlar bu haftanın konusu toss, store, load ve move komutlarımız var arkadaşlar. Bunlar bundan sonra tek tek move yazmamak, copy yapmamak için çokça kullanacağımız komutlardan. Öğrencilere en çok karmaşık gelen komutlardan da birisi aynı zamanda. Bu konuyu vizeye dahil edeceğim arkadaşlar. Normalde bu konuyu vizeye dahil etmiyordum. Biraz hızlı gitmiş olduk. Bu konuyu vizeye dahil edeceğim ama bu konunun basit hallerinden sorarsam. Önümüzdeki hafta yeni bir konu işlemeyeceğiz. Yeni konuya geçmeyeceğiz arkadaşlar. Çarpma bölme kısmına geçmeyeceğiz. Sizlerden soru cevap alacağım bir session şeklinde bir ders yapacağız. Sorularınızı biriktirin o yüzden. Şimdiye kadar çözmüş olduğumuz örneklere bakın. Yapamadığınız yerleri görün. Sorularınızı biriktirin. Önümüzdeki hafta derste sorularınızı alacağım. Onu baştan söyleyeyim. Onun dışında geçen haftanın konusuna hızlıca Türkçe bir giriş yapmış olayım. Geçen haftayı tekrar edelim. Belki gelemeyen arkadaşlarımız da vardır. ADC, add with carry arkadaşlar. Pardon arkadaşlar. Add with carry arkadaşlar. Toplama işleminin aynısı. Sadece carry ile hesaba katarak yapıyor. Carry 0 ise zaten toplama işleminin aynısı oluyor. Carry 1 ise ekleyerek yapıyor. Add with carry. Onu görmüştük. Subtract with borrow. Borrow dediğine bakmayın arkadaşlar. Aynı zamanda carry file'ye bakıyor. Hiçbir değişiklik yok. İki tane örnek çözmüştük. 32 bitlik iki tane sayıyı toplama, çıkarma ve işte büyük ya da küçükse toplama, çıkarma şeklinde bir if-else bloğunda toplama, çıkarma şeklinde iki örneğimiz vardı. İşte normalde bizim architecture'ımız 16 bitlik architecture olduğu için 32 bitlik sayıları toplayamayacağımızdan küçük bir hile kullanarak add with carry ile eldeyi diğer 16 bitlik kısma taşımıştık. Bir dakikanızı alacağım arkadaşlar. Arkadan beni ısrarla diğer hocamız arıyor. Benim de şu anda normalde dersim var. Kendi dersim, doktora dersim. Ondan çıkıp buraya geliyorum arkadaşlar. İki tane 32 bitlik sayı toplama çıkarmayı görmüştük. Normalde 16 bitlik architecture olduğu için bunu desteklemiyordu. Böyle küçük bir add with carry ve subtract with borrow'u kullanan örnek yapmıştık. Bu haftanın konusu load'lar, stoss'lar, loads'lar şeklinde demiştik. Herkes de geldiyse İngilizceye geçiyorum ve bu haftanın dersine başlıyorum arkadaşlar. Okay my friends, today's topics are stoss byte, stoss word, loads byte, loads word, most byte and most word. These are actually store, load keywords with the variation of word or byte, and also move, copying one element from to another element. There are some helpful instructions. We already see this clear direction, set direction flag. These are the direction flag set and clear instruction. And another important instruction is rep instruction. Rep instruction repeats one of the above, this is the toss, loads or moves instruction, CX times. It's actually creating a loop with rib keyword. Okay, let's start with stores byte. When we first learn a new instruction, remember, we open help part of the emulator, go to instruction set, and open the new instruction. It is stores byte. Okay, stores byte, store byte in AL into exasegment destination index couple. Update the destination index. The explanation is here. Algorithm is copying AL into exasegment destination index couple. If direction flag is 0, then updates direction index destination index with 1 by adding 1. If direction flag is 1, then update destination index with removing 1 from destination index. Let's copy the example from here. I'm not going to copy the Orcus example. Okay, I'm not going to use Lea, but I'm going to use move. Let's say destination index is, for example, 73. And AL has a 12H value. It directly gives the repetitive example. Sorry for that. Okay, let's emulate this one. Putting 73, sorry, we should put hexadecimal. 73 into destination index, as you can see in here. Destination index is updated with 73. We put 12 into AL. Now with stores byte instruction, as you can see, stores byte instruction doesn't take any operand. It's just a stores byte. So we write stores byte and no parameters. When we emulate this step, exasegment and destination index AL, copy it into exasegment destination index memory address. Let's go over and look at the exasegment and destination index address. Exasegment is 100. Let's go over and look at 100. And destination index was 73. As you can see, 1073 address has a value of 12 just by calling stores byte. Now I'm going to call stores byte again 3 times, for example, and run this trio of stores bytes. By the way, let's go back and see the destination index update. Destination index keep increasing, 73, 74, 75. I'm writing 73. 3 of these stores byte is run, and as you can see, 2 of them is written. The other is now written. Let's see this. 12, 12, 12. It's keep copying AL into memory. The memory location is exasegment destination index. So let's open a simple document. Copy this algorithm. Paste it here. Stores byte in AL into exasegment destination index memory address. Update destination index. This is byte version. Let's go over and look at the word version. This time it only gets AX, not AL, AX. Exactly same algorithm, but this time it will be word. To get AX, I'm not going to change this into AX, and I want you to see its stores word by word. So let's store these ones, go over and look at 73. As you can see, it stores word by word. This is AX, AL, AH. ALAH, ALAH. It stores word by word. You don't have to say anything, by the way, beforehand. It gets AX, whatever the AX value is. For example, stores word, I'm going to increment AX 2 times and run this example. We store AX, increment AX, store AX, increment AX, goes like that, and the storage destination on this was 1073, 12, 13, 14. Okay, this is exasegment destination index couple showing this 1073 address. Destination index is 73, exasegment default value is 100. Let's change the exasegment. I'm going to use BX in order to change the exasegment. Remember, you can't change directly a segment with an immediate value. This is wrong. You have to use a memory or variable, a register. Okay, who will say what will be the effective address of this exasegment destination index couple 12 will be stored with this instruction? Anyone? Let me open the text part. Anyone guessing the instruction stores word, where this instruction stores the word AX into memory? Location of the stores word used. For example, I ran this example. Go back and look at the 73. It's empty. It didn't return into yes, Ömer. What is the effective address? The physical address of this address you written. That is true, but it's combination of. When I enter, we will see the result. What will be the physical address of the emulator showing us, Ömer? Remember, we put 0 at the end of segment. In this case, it is 200. When we put 0 at the end, it becomes 2000. And we add the right part, which is 73. So it will become 2073. Yes, it writes into 2073, Salah. Thanks. So stores word, just a single instruction, doesn't take any parameters, and use exasegment destination index as a destination point to store AX. If it is stores byte, it stores AL. Okay? This is the things you need to know for now. Okay, if there isn't any question, I'm going over to load bytes. What we are going to do, we are going to open instruction set and look for the loads bytes. By the way, we forget to copy the algorithm into our text. This is store word, and here comes the loads byte. What it is doing, it load byte at memory in this location, data segment source index couple shows the memory location. It loads that memory value into AL. It loads. The name of it already states that it loads the value from data segment source index into AL. Okay, let's give an example. Let's say we write some value using stores word above, and I'm going to use loads byte I want to get value from that memory location. That's why I'm going to update data segment with using bx again. Update data segment 200 again, and I'm going to use loads byte. Lots of loads byte actually, and I want you to see the difference between byte and word. Okay. The previous examples, toss byte written into 273, 12, 0, 13, 0, 14, 0, etc. These are AX values word by word. Now I'm updating data segment with 200H. Data segment is now 200, as you can see in here. Now loads byte. What loads byte doing? It gathers the value from data segment source index, but we didn't use the source index. That's why let's put source index again. Okay. We updated the data segment. Data segment source index now shows the location of the value. We have put some values. Okay, let's run the loads byte. As you can see, AL becomes 12 because 273 memory location is 12, and we load byte. And please be careful, source index becomes 74, sorry, it was 73, now it becomes 74. When I run loads byte again, the location will become 2074 and the value is 00, AL becomes 00. We load the byte of AL and it becomes 0. Now the location is 175. The AL becomes 13, as you can see. Again, in the same example, I want you to show the difference between word and byte. There is one more important thing to mention. Source index and destination index automatically increase or decrease. But if it is word, the increase and decrease size becomes 2. Let's look at the destination index. It is 0 now. We put 73 into destination index. Okay, now we are going to use stoss word. Stoss word will update to destination index. As you can see, it becomes 75. It was 73, it becomes 75. Why? Because stoss word. When you go to stoss word instruction, the destination index update part is by 2. Stoss byte, it increased by 1. Okay? The difference between byte and word is stored in a single instruction. You don't have to do anything. If you put word in here, it increases the destination index by 2. If you put byte in here, for example, let's go over and look at the source index in here. Source index is now 73, it becomes 74, 75, 76. It goes one by one. Okay. So this is loads byte. Let's go over and look at the loads word. This is our algorithm. Algorithm says this time we are going to copy the data segment source index word part of this memory into AX. This is just a pointer. Remember, this is just a pointer to a memory address. We copy a value, a 16-bit value from AX, from this memory location into AX. And we update source index with 2 because it is word. And we take no operand, remember. Okay, I'm going to change this into load word. Go directly into load word part. I want you to look at the AL or AX completely. AX is 12, AX is 13, AX is 14. In order to use 16-bit value, let's put some bigger value into AX and emulate this one. Okay, we use those words and go over and look at the 2073. 1, 2, 3, 4, 1, 2, 3, 5, 1, 2, 3, 6. These are all words we use with store word instruction. Now I'm going to read those values into AX back. For example, AX is now 1236. Read the value. As you can see, we read the memory from 1234, 1235, 1236. Let's change this back into bytes and see the error. It reads byte by byte and it didn't read 36, 34, 38, etc. It's going to update only AL. AL becomes 34, AL becomes 12. Did you get the catch? Because it goes word by word. AL becomes 34, AL becomes 12, AL becomes 35 now. AL becomes 35. Bytes and words differ here. Be careful. Okay, we learned the load words also. We update our text. Moves word, moves byte and moves word. In our lab PDF, there's no moves byte because it's all the same. Let's go over and look at the moves byte. It copy a value from here to here. There's no register. When you call moves byte with no operand, it looks at the data segment source index and exit segment destination index couples and copy the value from data segment source index into exit segment destination index and update source index and destination index both at the same time by just calling moves byte. Copy algorithm, put it into our text. And how can we use this value? For example, 1000H address has a value of 73H. And I'm going to use moves byte command. Before using moves byte command, I want to copy this 73 into it is now in 1000 and the physical address is 1073 hash. I wanted to copy this 73 hash into, for example, 2073 hash. What am I going to do? I need to change exit segment destination index couples. That's why I'm going to update exit segment with 200 hash and put this bx into exit segment and use moves bytes. And it's already 100, no need to look at that. In order to this moves byte word, I need to update destination index also. For example, like this. The 1000 address stores 73. Oops, it's not 1073. It's 2000 memory address. Let me correct this. Addresses. This will be more clear. It is now in 2000 address because data segment is 100. Yep. It is now in 2000 address. We are going to update exa segment with 200. Exa segment is now 200. Destination index is updated with 1000. Moves byte. Moves byte is doing data segment source index. What is data segment source index? Source index is 0, data segment is 1000, so it is wrong. We have to update source index 2. Sorry. In the example we are going to cover this session, you would understand how useful moves byte is. This example a bit meaningless, but we will cover. Okay, we update the exa segment destination index and source index. So we are copying value from here to here. Okay, what we are going to try, we put value into here, 73, data segment is already 100. We copy this value into 200 exa segment part. Exa segment is 200. Source index, destination index. Let's put this over here. No change, but okay. We put exa segment destination index here, and we go over and look at 1000 in here. 2000 is 73. We want this value in 3000. Okay, moves byte value, find the data segment source index couple, which is 100 and 1000 become 2000. Get this value is here, 73. Get this value from the memory, put it into exa segment destination index couple, which is 3000. Let's run this code and see the result. Result is in 3000. As you can see, it puts the value into 3000. Source index and destination index is updated. As you can see, they are blue. Updated registers are blue. Instruction pointer is always updated. We only call moves bytes. It calculates data segment source index, copy the value from data segment source index, and calculate exa segment destination index, copy this value into exa segment destination index back with a single instruction. Okay, the importance is this. If you use word, it's going to get a word from some address, update this source index and destination index by 2, according to direction flag, by the way. Direction flag default value is 0, which become increase, which means increase, which means forward. Let's run this example. Value is in 2010-2001 address. It is word 1173, and when we run this moves word command, it will store in 3000 and 3001 addresses. As you can see, this is moves word. Okay, let's go over and copy the moves word. Okay, this is the algorithm. I'm going over and looking at the PDF, which shows clear direction and set direction flags. For example, let's use set direction flag in here at the beginning of this example. I'm going to open the flags. Please look at the direction flag. Direction flag is set by set direction flag instruction with std. Direction flag is now 1, which means backward, which means after running a single moves, stores, or loads word instruction, it will update the source index and destination index by decreasing. For example, let's go over and look at, please look at here, source index and destination index. They are decreased by 1, decreased by 2, sorry, because this is word. If you use multiple times, use by this time. Okay, we have a value in 1008 address, 2010, 2001. Moves byte, when we run the first moves byte, it will get the and copy it into 3000, but the second moves byte will get the empty part of this memory, one above. This byte will be copied into 2010 FF, will be copied into here, 2FFF value. So I run this value, source index and destination index is updated. Let's go over and look at the values. It was empty, but just to be checked. 11 is not copied from 2001 address. How we are going to change this? Let's change these addresses into 1 and copy the higher part first and lower part later. Okay, the address is 1173. By this calling, we calculate the reverse version of 1173. It's it's put into 1001 because this part is in 1001, this part is in 1000. It copies first the lower part, then the upper part, and decreased. So nothing is changed if we start from 1001. So it's up to you. You have to be careful using these flags, directions, ways. Clearing direction flag is CLD, setting direction flag is STD, and there is also one more important instruction, repeat instruction. This is important. Let's go over and look at the rep command. Rep command, repeat, moves byte, moves word, loads byte, loads word, stores byte, stores word. Only these 6 instructions. We have written these 6 instructions. These are string operation, by the way, if you see in anywhere. You have to use rep instruction, before this 6 instruction, you can't loop add, for example. You can't use like this. This is wrong. You can't repeat an add function. You can only repeat this 6 instruction. Okay. How many times this is going to count? It will store it into CX, exactly like loop. So I'm going to use move CX2. This is the same operation we do in the previous example. We put 1173 in here, copy this 2001 into 3001, decrease the value, copy this 2000 value into 3000 by using rep this time. For example, this will run once. I'm going over and look at the 3000 part. It didn't run yet, sorry. 11 is copied. Run again. Now the 73 is copied. This is run 2 times. You can change this by putting some other values into CX. This will run multiple times, but the memory is empty at that positions, so this is meaningless for now. Okay, let's see this in action in examples. Is there any question about this example, these comments, repeat comments, flags, etc.? Any question? Okay, then I'm diving into examples part. Okay, write a program that stores value of B, C, D, E. We are going to store this value into this memory range. Keep copying this value into this range. Okay, let's write this example. I'm just deleting all. Okay, we have a BCD value. We are going to store. We are going to store this value into this memory range. That's why I'm going to use stores byte or word. Who is going to say what I'm going to use? Byte or word? Word. Ömer says word. Yeah. Why? Because our value is 16-bit value, which is word. I'm going to use word. Stores word algorithm. What was that? It was copying AX value into hexasegment destination index. So I need to update hexasegment. Hexasegment is 100. It's already 100, but I'm going to write it again. Hexasegment is updated. Hexasegment destination index. Destination index is 300. I'm going to update destination index with 300H. And this stores word will copy AX value into hexasegment destination index address. So I need to put BCDEH into AX. Let's see this example. Okay, we put 100 in AX, update hexasegment with 100, it's already 100, destination index with 300, and put BCDE into AX and use stores word. When we go over and look at the 300, BCDE is stored into 300. But this example wants us to store BCDE in all within this range. So I'm going to repeat this toSword comment. How many times do I have to repeat? How many times? Any guess? FF divided by 2. So you want me to make calculations, Ömer? You are that lazy. Not it's problematic. FF divided by 2 becomes 7F, or 100H divided by 2 becomes 80H. So I'm going to put 80H into CX and repeat this toSword 80H times. Okay, emulate this again, run this command. It's repeating. As you can see, it keep using toSword again and again. Go over and look at the 300 BCDE, BCDE, BCDE, BCDE keep storing into value until, let's continue this run, finish it, go over and look at the FF value. Yep, BCDE. So it is 80H. We calculated it. Okay. Question is this. Any question about the example 1? Is there anything you didn't understand? We repeat the toSword by CX times, which is 80. Just because the memory range is FF 00 to FF, we subtract FF from 00 and divide it by 2 because the value is word. We copy this word into memory with toSword. Okay, second example, if there isn't any question, there is no question. Second example, write a program that reads value between the previous memory range and subtracts 1, 2, 3, 4, 8 from these values and write results back to the same address. Okay, we get the value from the address, which is, remember, loads word. We are going to use word because we are going to subtract 1, 2, 3, 4, 8 from word. Loads word. What was loads word was doing? Loads word was doing data segment source index into AX. We need to get the value from data segment source index. So I need to update source index 300, starting from that address. Data segment is also needs to be updated. Let's use AX again. I'm updating data segment with AX. Okay, now loads word looking at data segment source index, which is 100 and 300H address. Put this value into AX. After this loads word operation, I need to subtract 1, 2, 3, 4 hash from AX. Result will be in AX. After this operation, I'm going to store the result back into memory address, which is toSword. toSword use the exe segment destination index. Remember, that's why before this operation, I need to update destination index into 300 again, so that I'm going to read from exe segment destination index and write it back into data segment source index. Okay, Couples are important. Okay, so I need to do this 3 code 88 times. I need to repeat these codes. You can't use rep something, rep like this, because rep command only repeat a single line CX time. That's why we need to make a loop. I'm going to use CX again with 80H, need a label. After this label, we need a loop keyword, put Abbas at the end, and see the result. Okay. I want to decrease these values, but let's not decrease. Run this example. Okay, stores word is running. Subtraction is going on and halted. Let's go over and look at the memory address of this location. Sorry, this location, which is 300. AAAA. What is AA? AA means BCDE minus 1, 2, 3, 4, which becomes AAAA. So it writes back AA into memory again. Okay. This is the first question. This is the second question. Now, if there isn't any question about the second question, I'm going to dive into third example. Okay, third example. Write a program that reads values between this memory range, exactly the same range above, reads those values and writes back these values to memory address between here. This is actually copying an array. There's an array in 300H. It wants you to copy this array into 300 and 500H. What we are going to do, we are going to use moves command. Doesn't matter if you use moves byte or word, it's up to you. But if you use byte, you have to be run repeat command or loop in FF times. If you are going to use word, you have to repeat 80H times. So I need to use moves, let's say word command. There's no subtraction, addition, anything, we just copy. That's why I'm going to use repeat this time. Repeat command will run CX times. CX is 80H because I use word. If I use byte, this needs to be 100H. I use words, that's why it becomes 80H. Okay, moves words, look at the exa segment. Let's open the algorithms. Moves word, look at the data segment source index and copy this value into exa segment destination index. In our question, this is our data segment source index. This is our exa segment destination index. So write this value into comment section. This is our data segment source index. And this is our exa segment destination index. Couples are important. Don't make mistakes. Okay. After this, all instructions, CX is updated, destination index is updated, source index is updated. That's why I need to put new values into them. I need to update source index, which is 300H, update destination index, which is 3500H. Exa segment and data segments are same. They are all 100 for now. Yep, that's it. This operation will... Okay, let's first store BCD, subtract 1, 2, 3, 4 from it. After that, copy this memory into somewhere else, where it is 500H. 3500H. Okay, we copy the memory array into something different. So this is the third question, third example. Any question? So there is no question.
Evet, tekrar merhaba arkadaşlar. Abbas hocam teşekkür ederim.
Ben teşekkür ederim hocam. Soru da yok.
Arkadaşlar katılımınız için teşekkür ederim. Hoşça kalın, sağlıcakla kalın. İyi günler. Kaydı kapatıyorum hocam.
Teşekkür ederiz hocam.
Ben teşekkür ederim hocam.
İyi günler hocam.
İyi günler.